Hi everyone, it's Coach Fred here, and today I'm going to be talking about proper order of operations. And in my opinion, I don't think we can talk about proper order of operations without actually talking about the difference between an expression, a mathematical expression, an equation, and a function. And I think that if we have a really good understanding of these three things, it will help us as we move forward with our math understanding. All right, so an expression is basically just a general term for any well-formed combination of mathematical symbols. So, for example, 2x, that's an expression. 3x plus 1, that is an expression. Expressions we do not solve. They do not have equal signs. So they do not have an equal. So we basically don't solve expressions. We simplify them and we evaluate them. Okay? And it is important to know that with expressions, we must follow a proper order of operations. We're going to talk about that in a minute. Okay? We must follow a proper order of operations. Oh, I'm getting a little messy there, sorry. All right, so what's an equation then? Well, I like to think of an equation as an expression equaling an expression. That will help us understand how we work with equations. It's also important to know that when we solve an equation, equations are going to have an equal sign. When we solve them, we're finding the value that makes it true, makes the sentence true. So when we solve an equation, we are finding the value that makes the statement true. We are finding the value that makes the statement true. Okay, so let's just talk about a basic equation. So x plus 2 equals 5. 5 is a mathematical, statement, just a mathematical term, so it is an expression, and x plus 2 is a mathematical expression, so I have an equation. I have an equal sign, so I can solve it. We solve equations, right? All right, so when we solve, in this case, x would equal 3. Well, that answer, 3, if I plug it into the original statement, makes the equation true. 3 plus 2 does equal 5. Okay, but that leads us into the things that can happen with equations. We can get a solution. We can get no solution. And we can get all real solutions. All real solutions. So let me go back. Let me go back to that. I'm going to erase this for a second. Let's pretend I gave you the expression 2x plus 5 equals 2x minus 3. So I have an expression equaling an expression, so I have an equation, and I would solve it. And some of you might see right off the bat the answer to this, but others might try to solve for x. So what would you do? You'd subtract 2x from both sides, and you get this statement, this equation, 5 equals negative 3. Well, that is not a true statement. So that's telling me that there's no value of x that will make this a true statement, and that's an example of no solution. Now, some of you saw right off the bat that there's no number that I can put in for x, that if I add 5 and subtract 3 from that number, I'm going to get the same value. So some of you might have seen it right there. But again, we solve equations. All right, well, what if I did this? Well, mathematically, if you went to solve it, you'd be left with 5 equals 5. That's a true statement, which means the answer will be all real numbers. All values of x will make this expression equal this expression, okay? So remember, the equals just means is the same as. So those are the things that happen with equations. But back to it. Expressions we simplify and evaluate. Equations we solve. Now functions are different. Functions have inputs, which are our x values, and outputs, which are our y values. So functions are going to have two variables. Now, they also have an equals, so we like to call them function equations, okay? But they're going to have two variables, and so we do not solve functions. We do not solve functions. We take inputs, and we get an output, and we get to assign them. Often when you learned about functions, you would make tables of values. And let's just say I gave you the function y equals 3x minus 1. Okay, so we would take an x, any x we want. So maybe 0. We plug 0 in for x. So 0 times 3 is 0. And so we get a y of negative 1. So when x is 0, when x is input into the function, the output is the y, which is negative 1. So we graph functions, okay? And we want to make sure we understand the difference between an equation and a function. When we solve an equation, it has one variable. It's an expression equals an expression. A function is going to have two variables, which means we're going to come up with inputs and we're going to get very different outputs. Very, very different. All right, so now this leads us into order of operations. We really use order of operations on expressions. So if I'm working with an equation, you have to use the proper order of operations to this expression and to this expression. Solving the equation is actually not order of operations. It's actually backwards order of operations. All right, the order of operations I like to use, the terminology I like to use is Gemdas. Now I know some of you use PEMDAS, but I'm going to throw that one out for a second. The reason I don't like PEMDAS is because P, you've always seemed to think of as parentheses. But there's a lot more things that Gemdas includes. G stands for grouping symbols. And there's lots of things that you might not think of as grouping symbols. Parentheses for sure, brackets, fraction bars, square roots. Everything, there's so many different options for grouping symbols that have to be done first. Then we move on to exponents. This is where lots of kids make mistakes. So for example, if I give you 2 times 3 squared, I have to do 3 squared before I multiply the 2 times the 3. So we'd actually have to do 2 times 9. All right, multiplication and division come together, whichever one comes on the left, because we work from left to right. And then addition and subtraction come together, again, from left to right. So if subtraction is on the left, before the addition, we should do that first, okay? So we work with them together. All right, so let's look at an example. Here we go. So here's an expression. Again, it does not have an equals, so we know we're going to simplify it using proper order of operations. All right, so that would tell me I have to do the parentheses first. So there's nothing in the parentheses that I can do. It's already simplified. So then I move on to exponents. So I'm going to do negative 2 to the 4 power. Negative 2 to the 4 power is going to give me 16. Okay, then I am going to work with, because that fraction bar is a grouping symbol, I'm going to do everything on the top first. I can't cancel the 16s yet, okay? All right, so I've got to do negative 16 times 3, which is negative 48, and then I have to divide that by 2. That's going to give me negative 24 all over 16, and then I'm going to simplify that to, so 8 goes into both of them, so negative 3 over 2. Okay, all right, let's look at another example. Here we go. Order of operations tells me I have to do grouping symbols first. So I have to go in here first. So I have 2 minus negative 2. Those two negatives become positive. So that gives me 5 squared minus 6 times 4 squared. Now I deal with my exponents. So I have 25 minus 6 times 16, okay? So 6 times 16 is because I got to do the multiplication next, is 96. And then 25 minus 96 is going to give me negative 71. Okay, so let's just review. Grouping symbols first, exponents, multiplication and division, and addition and subtraction. That's the proper order of operations, and we use that to simplify expressions. All right, hopefully that was a helpful video. Have a great day.